Hi everyone. So this is the last topics for chapter 6. We're going to be going over empirical formulas, and how to get to empirical formulas and molecular formulas as well. So let's start off with some of the slides on Canvas. So definition of empirical formula. What it represents, an empirical formula, is the simplest ratio of the kinds of atoms in that compound. So you basically reduce down to the simplest ratio for each kind of atom. A molecular formula, on the other hand, describes the actual number of atoms of each element in the molecule. So there's a relationship between the molecular formula and the empirical formula, and they differ by a factor. It's some factor. It could be 2, 3, 4, 5, etc. Okay. So here's an example. Let's say that you have hydrogen peroxide. The hydrogen peroxide molecular formula is H2O2. So the molecular formula tells you the true number of atoms of hydrogen peroxide, which is 2 hydrogens and 2 oxygens. Okay. But you can also say, you can also represent hydrogen peroxide's empirical formula, which would be the most reduced form of that formula. And the way to think of it is to find the largest factor that you can divide by. So if you have 2 and 2, you can divide both by 2 to get whole numbers still. So if you divide both by 2, what you get is H and O, right? So the way you can think about it is just reducing it, right? Taking these large numbers and reducing it down to the smallest whole numbers that you can get to. Okay. Here's another example. Glucose would be C6H12O6 for the molecular formula. And if you look at those numbers, 6, 12, and 6, and think about how to reduce those down to the smallest whole numbers, you'd find that the common factor that you could divide by is 6, right? So if you divide carbon's number of 6 by 6, then you get 1. Hydrogen 12 divided by 6, you get 2. And then 6 divided by 6 is 1. So the empirical formula of glucose is CH2O. So you guys get an idea here, right? That the empirical formula is just a factor, some whole number factor away from the molecular formula. In hydrogen peroxide, you see that the factor is 2, right? So if you multiply the empirical formula by 2, you get the molecular formula. In glucose, the factor is 6, right? So if you multiply the empirical formula by 6, you get back the molecular formula, right? So they differ by a factor. Now, let me show you something on the board as well. It's not just the atoms that differ by a factor. It's also their mass, which makes sense, right? So if hydrogen peroxide's mass, and we would just calculate the molar mass here, 2 times 1.08 plus 2 times 16. So the molecular mass of hydrogen peroxide would be 34.02 grams per mole. Okay, if you calculate it for HO, well, that's 1.008 from the hydrogen, just plus 16.00, which is 17.01 grams per mole. So what do you see? The mass of the empirical formula has the same factor, right? And the factor there is 2 to the molecular formula. So if it takes a multiple of 2 to get from the empirical formula to the molecular formula, it will also take a multiple of 2, right, to go from the empirical mass, right, empirical mass to the molar mass, right? It differs by the same factor. Okay. So if you keep this in mind, later on when we get to the part where we do how to determine a molecular formula, this will come in handy, right? So again, just remember that they differ by a whole number factor, right? Okay. Let's go back to our slides. So now I'm going to show you guys how to calculate empirical formulas. There's certain steps. I'm going to actually write it on the board. It's going to be easier. Steps to determine empirical formula. So go ahead and get a piece of paper and copy this down with me. So there we have it, the steps for determining the empirical formula. So I'm going to read through it, and then I'm going to give you guys some examples, and we're going to work through each of these steps so you guys know exactly what each step is talking about. Step one, you're going to assume a 100-gram sample. So most of these empirical formula problems will give you a percentage of the element. Like, oh, this compound contains 64% carbon and 10% hydrogen, so on and so forth. So if you assume a 100-gram sample, the percentages can be converted straight to grams. So in a 100-gram sample, if 54% of it is carbon, then that also means I have 54 grams, right? So it makes it really straightforward if you assume a 100-gram sample, and you can always do that. Then step two, you got to take grams and convert to mole using the molar mass, which we've done a lot already, right? Step three, you'll write a pseudo formula using the mole numbers that you calculated in step two as subscripts. And then you got to divide the smallest subscript to get the whole number. Step five, if it's still not a whole number, you can multiply by the smallest factor to get a whole number. And the way I would do it easiest is just start with a factor of 2. And if that doesn't work, if you multiply by 2 and it's still not a whole number, then try 3, then try 4 and 5, right? Eventually you'll get to a whole number, right? So that's the goal, right? Because formulas are never fractions or decimals. So you're always trying to get to a whole number. Okay. All right. So let's go to an example. We can pull one up from our slides here. So here, this one says, an ionic compound used in the brewing industry to clean casks and vats in the wine industry to kill undesirable yeast and bacteria is composed of 35.172% potassium. So I'm going to write this on the board. So we have these numbers to work with. Have the steps that I just showed you out in front of you. So we have 35.172, it says, percent of potassium, 28.846% sulfur, and 35.982% of oxygen. Okay, so from these mass percents, we can actually figure out what the empirical formula of the compound is, right? And why is this useful? Well, it's a piece of information, right? Just imagine you have an unknown compound and you put it in a machine and it tells you these percentages. Well, you're at least able to get the empirical formula, right? That's already a piece of information. And from that empirical formula, perhaps you can do more tests in order to figure out what the compound actually is, right? So it's a very useful lab technique, right, in order to figure out what your unknown is. All right, so remember those steps? Remember, step one was if you assume that you have a 100-gram sample, then 35.172% potassium is the same thing as having 35.172 grams of potassium, right? That's what makes it easy. And 28.846% of 100 grams is also 28.846 grams of sulfur. And that means I also have 35.982 grams of oxygen, okay? So the percent goes straight to grams when you assume 100 grams. And then remember step two. Step two says you're going to convert each gram to mole because in a formula, those subscripts are moles, right? And not grams. So you can't leave it in this format. You've got to convert it to moles using the molar mass, right? So if you want mole, then mole's got to go on top. 1 mole of potassium. And then you're going to look up potassium on your periodic table. And it is 39.10 grams of potassium. Okay, so that cancels. Yeah. Let's set it up too. Let's set it up for also sulfur, and then we'll do the calculations all at once. So 1 mole of sulfur is 32.06 grams of sulfur. That's also from the periodic table. And then oxygen, 1 mole of oxygen we know is 16.00 grams of oxygen, right? Always, we want moles on top, right? Because that's what we desire. So let's calculate for each of these the mole. Zero 0.8995 moles of potassium. Now, here's a tip. At this point, I would keep at least 4 sig figs. Do not round too much. In these types of problems, if you round too much, you're going to get the answer wrong. You want at least 4 sig figs. So don't round too much. Okay, for this next calculation, I get 0.8998 moles of sulfur. And this last one, 2.249 moles of oxygen. Okay, so this was my step 2, right, everybody? Turning the grams into the mole. We get to my step 3. Step 3 says, write a pseudo formula using moles as your subscript. So what's my pseudo formula? Well, potassium is 0.8995. Sulfur is 0.8998, and oxygen is 2.249, right? So why is it called a pseudo formula? Pseudo means fake. This is obviously a fake formula. What kind of chemical formula has decimal in it? You've never seen that, right? And so that's why it's called a pseudo formula, but it's useful to write it at this time because now it's really easy in your next step to figure out what is the smallest subscript. It would be this one, right? Just pick the smallest number and you're going to divide it by that number for everybody. For each subscript, you're going to divide it by that smallest subscript. And the result is, well, obviously it's going to be 1 for K and it's 1 for S as well. And then let's see for oxygen. Oxygen is 2.5. Okay, so at this point, we're still not done because again, formula should not be in decimal, right? And so that's why step 5 says, if you still have a decimal, you're going to multiply by the smallest factor until you get to a whole number. So you're going to start with 2. Let's try multiplying by 2. You multiply 2.5 by 2. You get 5. Great, that is a whole number. So 2 works just fine. So you're going to multiply everybody by 2, right? Every single atom by 2. So K1 here is going to become K2. There's a 1 here, right? 1 times 2 is 2, so sulfur is 2. And then 2 times 2.5 is 5. So K2 S2O5 is going to be our empirical formula. Okay. So as you can see, you follow my steps, right? And this is your step 5 here, right? Just 5 steps. Follow those steps, and you're gonna get the answer, right? The answer is gonna fall in your lap, and it's pretty straightforward. All right, let's do another one. Okay, so that's the same one. Let me put on the board another one for you guys. Okay, so in this next example, we have vitamin C, and it's put through an elemental analysis instrument, and it says that it contains 40.92% carbon, 4.58% hydrogen, and 54.50% oxygen. So now it asks for the empirical formula of vitamin C. Okay, so step one, right? Remember, we're going to assume 100 grams. So that means we have 40.92 grams of carbon. We also have 4.58 grams of hydrogen and 54.50 grams of oxygen. Okay. Step two, right? Remember, we're gonna take the grams to mole. So 1 mole of carbon on top, 12.01 grams of carbon on bottom. For hydrogen, 1 mole of hydrogen on top, 1.008 grams of hydrogen on bottom, right? So getting all of these from the periodic table, right? The molar mass. 4 grams of oxygen, 1 mole of oxygen, 16.00 grams of oxygen on bottom. And let's get these numbers. .407 moles of carbon. 4.544 moles of hydrogen. And 3.406 moles of oxygen. Okay, so that's step two, right? Converting grams to moles. Then step three, we write the pseudo formula using the mole numbers as subscripts. So for carbon, it's 3.407. Hydrogen is 4.544. Oxygen 3.406. That's our pseudo formula. Step four, it says you're going to divide each subscript by the smallest one. So the smallest one is 3.406. You're going to divide everybody by 3.406. And so what are you going to get? Looks like 1 for carbon, right? For hydrogen, it's 1.33. And for oxygen, it looks like 1 as well. Okay. So at this point, we see that we're still not done. If it had been whole numbers, then you're good, right? Because we're aiming for whole numbers. But at this point, okay, it's still not a whole number. So remember, we're gonna have to multiply by some factor, okay, in order to get to a whole number. And let's start with just a factor of 2, the smallest factor. So take 1.33 times 2, and I get 2.66. That's not it. That's not a whole number. Let's try 3. So I'm going to take 1.33 times 3. Oh, I get 3.99. That's really close to 4. When you get a number like that, guys, if it's 0.1 within a whole number, round it to the whole number. Okay, so I get 3.99. That's pretty easy to say I should round to 4. But if you have 3.95, I'd still round it to 4. If you have 3.90, I'd still round it to 4. Okay. So if it's within 0.1, it's safe to round it to the whole number and you're good. All right. So it looks like 3, right? 3 is the factor that we need. So we need to multiply each subscript by 3. So 1 times 3 is 3. So you got C3. 3 times 1.33 is 4. So we have H4. And O1 times 3 is 3. So we have CH3, C3, H4, O3 as our empirical formula. All right. Let's move on. We're going to go to the next topic where we calculate molecular formulas. So going back to the slides and the exercise that I told you guys earlier, remember how a molecular formula and empirical formula differs by a factor, right? Because you're cutting it down, right? Remember, you're reducing it down to the lowest possible whole number. So if you take the molecular mass, right, and the mass matters too. So the big mass, and you divide it by the small empirical formula mass, you will get that factor n. That factor n is what separates the empirical formula from the molecular formula, right? And so you just multiply back up by that n factor to get to the molecular formula. Okay, so let's do this example. PCB, it's basically, it's a polychlorinated biphenyl, and it's used for a lot of things. It's used to insulate fluids in electrical transformers. But anyways, when it's analyzed, what we get is 39.94% carbon, 1.12% hydrogen, 58.94% chlorine, and it has a molecular mass of 360.88. So let me write that all down on the board, and then we can solve it. Okay. So there, I got the main things, right? Here's the percentages, and it also tells you the molar mass of the entire compound. So it's asking, what is the molecular formula of PCB? Okay. So before you can get molecular formula, you will need the empirical formula. Okay, so go through all your steps first to get the empirical formula, and then you can get the molecular formula. Right? Okay, so let's do it. We have 39.94% carbon, which means if we assume 100 grams, you also have 39.94 grams of carbon. We have 1.12 grams of hydrogen and 58.94 grams of chlorine. We're going to convert those to moles. So for carbon, it's 1 mole over 12.01 grams of carbon. For hydrogen, 1 mole of hydrogen is 1.008 grams of hydrogen. For chlorine, 1 mole of Cl is 35.45 grams of Cl. And let's grab those numbers. .326 moles of carbon. 1.111 mole of hydrogen. 1.663 moles of chlorine. Okay, next step would be write the pseudo formula. Okay, that's be the pseudo formula. And then we're going to divide by the smallest subscript, which is 1.111. So that's going to give us, it looks like 3 for carbon. Let me check. Yeah, it looks like 3 for carbon, 1 for hydrogen, and for chlorine, 1.663 divided by 1.1. For chlorine, it's 1.5. Okay, so at this point, you know, I still have a decimal. So I'm gonna multiply by the smallest factor. So take that decimal number, 1.5 times 2 is 3. Okay, great. So 2 works. So I'm gonna multiply everybody by 2. C6H2Cl3 is going to be my empirical formula. But it doesn't want an empirical formula, it wants a molecular formula. So remember how they relate, right? They're a factor from each other. And the mass is the same factor. So it already gave you the big mass. Okay. If you take the big mass and you divide by the small mass, you should get that factor. So all you need to figure out is what is the small mass? What is the empirical formula mass? It's fine, just add it up. 6 times 12.01 plus 2 times 1.008 plus 3 times 35.45. $180.43 grams per mole. Okay, so we have the small mass as 180.43 grams per mole. The big mass is 360. So to get that factor of n, just take the big mass and divide by the small mass, 180.43. That's going to give you 2. Okay. So the factor is 2 that separates the empirical formula from the molecular formula. So if we multiply this by 2, okay, we multiply this by 2, then we get C12H4Cl6. And that is going to be your molecular formula, right? So again, every time, right, just take the big mass, divide by the small mass, which is the empirical formula mass. You figure out what that factor is that separates the empirical formula from the molecular formula, and then just multiply up, right? From the empirical formula, just multiply up by 2 to get to the molecular formula. So your answer is going to be C12H4Cl6. Okay, so that's it, guys. For this lesson, go ahead and go and practice and knock a few out for yourself. Make sure you can do it, and let me know if you guys need help. Come to office hours. I'll see you guys at the next video.